All right, today you guys hopefully finished your exam on chapter 5. Only two sections, so hopefully finish that. I'll check those out this week. Today we're going to start chapter 6, applications of definite integrals. Now, integrals find areas under curves. That's from calculus 1. Now we're going to look at volumes using what are called cross sections. There are three types of methods we're going to use here. Oh, oh, I missed the last half hour of what we're doing. Okay, number 6. Find the volume of the solid generated by revolving the region bounded by y equals radical x and the lines y equals 1, x equals 4, about the line y equals 1. Find the volume of the solid generated by revolving the region bounded by y equals x and the line y equals 1, x equals 4, about the line x equals 4, about the line y equals 1. Okay. So what does that mean? Let's look at our picture. What's our graph look like first? Right, so it looks like that. When x is 1, y is 1. 2, 3, 4. When x is 4, y is 2. So there's the line x equals 4 is right here. We'll stop there. Y equals 1. So you see what we are revolving? We're revolving this part here. So we go down 1. As it revolves. This is the area, this is the volume we're looking for here. All right. So what's our formula? What's our area? No, because our formula is, I'm sorry. Yeah, because our equation has to deal with that equation. But we're only up to this one. So our equation that we're dealing with because we are revolving about the line y equals 1. Okay, well, that then times pi. This is our radius. Our radius is x minus 1 pi r squared. So we have to square this. So FOIL this, we get radical x minus 1 times radical x minus 1 times pi. That's what this says. Radical x is x minus 2 radical x plus 1 pi. So that is our area. What's our bound of integration? Yeah, because that's where our graph starts at 1, it goes to 4. So the volume is from 1 to 4, ax dx by x minus 2 radical x minus 1 dx. The pi can go out in front since it's a constant. It's a plus 1. The integral of x is x squared over 2. What's the integral of 2 radical x? 2 radical x becomes 2x to the power 1/2. When we integrate it, add 1 to the exponent, it's 3/2 over 3/2. So it's 2 times 2 over 3 x to the power 3/2. And 1 becomes x. There. From 1 to 4. Four squared over 2. This becomes 4. 4 over 3. 4 to the 3/2 plus 4. minus 1 squared over 2, 1 to 3/2 power, 1. Sixteen over 2. Square root of 4 is 2. 2 to the third is 8. 1/2. That's 1, so it's minus 4/3 plus 1. Sixteen over 2. 32 over 3. 4 over 1. Minus 1/2 minus 4/3 plus 1. The LCD is 6. So by 3, by 2, by 6, by 3, by 2, by 6. Sixteen times 3 is 48 over 6. 64 over 6. 24 over 6. 3 over 6. 8 over 6. 6 over 6. So 72 minus 64. 48 plus 24 is 62 or 72. 72 minus 64 is 8. 8 over 6 minus 9 over 6 minus 8 over 6 is 1 over 6. So it's 7 pi over 6. What do y'all think? A lot of writing. Again, that's all algebra. If you had a calculator, you just throw it in there, but it'll give you a decimal. Yeah, so to get the LCD, I multiplied this one by 3 over 3, 2 over 2, 6 over 6. 3 over 3, 2 over 2, 6 over 6. Now we're going to take integrals rotated across the y-axis this time. You use the same methods we did earlier for X, but now we rotated it about the Y axis. Everybody got this? All right. If we rotate about the Y axis, our area now becomes A of Y, becomes the pi times the radius with respect to Y squared. Now we're looking at the volume by disks. Rotated about the Y axis. Just treat the same way you did, but instead of treating with respect to X, treat it with respect to Y. Let's look at this one. Ready? Find the volume of the solid generated by revolving the region between the y-axis and the curve x equals 2 over y, bounded from 1 to 4, about the y-axis. Find the volume of the solid generated by revolving the region between the y-axis and the curve. What does that curve look like? What is 2 over y look like? Or even what is 2 over x look like? What does that graph look like? Yeah. So the larger x gets, the smaller y gets. But the smaller x gets, the larger y becomes. So the graph of this one would look like this. And since we're only dealing with the positive side, we're going to look at this. And when we rotate it about the y-axis, this is what we're going to have. So our graph looks like this. Rotated about the y-axis. That's what we're looking at. What's my first step? I drew the picture. Second step. What's the formula for the area? This time it's with respect to y. So it's pi r squared y equals pi. The radius is 2 over y dy. So our formula is going to be with respect to v. What's our bound of integration? One to 4. y dy. By 2 over y squared dy. So it's 4 over y squared dy. Over y squared dy. Okay, so this one, if we add 1 to the top and add 1 to the bottom, we get -1 over -1, which gives us -1 over y. So that would be the integral. -1 over y from 1 to 4. Because since this is a denominator, it turns to negative. Add 1 to the top, add 1 to the bottom, we get this. So this is going to make it negative. It's going to be 1 over y negative. 4 pi, not y. -1 over 4 minus -1 over 1. This turns into a plus. It becomes 4 over 4. Four minus 1 is 3 over 4. The 4's cancel. So our volume is 3 pi. So far, so good. All right, let's look at the next example. That. All right, I'm sorry. Focus. Find the volume of the solid generated by revolving the region between the parabola x equals y squared plus 1 and the line x equals 3 about the line x equals 3. what's the graph going to look like? What's this parabola going to look like? Now we're going with y. It would be up if it was y equals x squared, but now it's going to be to the side. And since it's plus 1, that's the smallest it can be. So it's going to be a parabola like this. And we're going to go all the way to 3. Okay, that's the first part. Find the volume of the solid generated by revolving the region between the parabola and the line about the line y equal or x equals 3. So it's rotating about this line. It's going to look like that. So what do we do from there? Do we have the graph? Do we have the formula? What's it going to be? Okay, so let's look at this. X equals y squared plus 1. But this is a function with respect to y. This is x with respect to y. So do we have to change it at all? So that's going to be our radius. So our area is pi r squared. Pi r with respect to y squared. And what is y? I mean, what is r? Y squared plus 1. This is, let me see, it says parabola y, x equals y squared plus 1, and the line there. It's shifted over to 3. So r is shifted over to 3. And okay, yeah. Which is 3 minus. So that's our radius. Because we shifted it would have been the other way if we started at the origin, but we did. We shifted over 3 spaces to the right first. we shifted 3 spaces to the right. So we shifted 3 right minus our function. So 3 minus this, it's going to give us each of these concentric circles horizontally. Because if we set this equation equal to 0, we get x equals 3, which is where that is. So it was a shift to the right 3 spaces. And what is x? X is our function. So that's our radius. So our area now becomes pi r squared, pi 2 minus y squared squared. Yeah, so our volume is going to be from where to where? What's our bound going to be? Because it has to be with respect to y. The only thing we have with respect to y is this equation here. Do we know what x is? Not yet, no, because we can't have two variables. For the bounds, we need to have numbers. Since we're integrating with respect to y, do we know what x equals? Yeah, x equals 3. So to find the bounds of integration, we use x equals y squared plus 1 when x equals 3. So we have 3 equals y squared plus 1. Subtract 1 from both sides. Y squared equals 2. Square root both sides. Y equals plus or minus square root of 2. Those are our bounds. So we go from negative square root of 2 to positive square root of 2. Two minus y squared squared dy. That's all of calculus. You want me to go up or down?
No, I'm just trying.
Oh. Read my handwriting?
No,
Okay. That's a nice way of saying my handwriting sucks. Okay, so what do we do first here? Negative radical 2, radical 2. We have to FOIL this one. 2 minus y squared times 2 minus y squared becomes 4 minus 2y squared plus y to the 4th dy. We had to FOIL, and that gave us that. Now we integrate each part separately. Four becomes what?
Mm,
Y. Y cubed over 3. Oh, no, it's 4, not 2. It's 4. Because it's 2y squared plus 2y squared is 4y squared. So it's 4 in front of there. That's something weird. Y to the 5th over 5. Four radical 2 minus 4 radical 2 cubed over 3. Radical 2 to the 5th over 5. Negative 4 radical 2 minus 4 negative radical 2 cubed over 3 plus negative radical 2 to the 5th over 5. Radical 2 cubed is equal to 2 radical 2. So that's minus 8 radical 2 over 3. Radical 2 to the 5th is radical 2, 2, 2, and radical 2. So it's 4 radical 2 over 5. Negative and negative becomes a positive, and this becomes 2 radical 2. So it's positive 8 radical 2 over 3. It's an odd power, so it becomes minus 4 radical 2 over 5. Change the signs, that becomes a plus. This becomes a minus, this becomes a plus. Four radical 2 plus 4 radical 2 is 8 radical 2. Negative radical 8, that makes it 16 radical 2 over 3. Plus 8 radical 2 over 5. 15 is the LCD. So 15. This one's times 5. This one times 3. $40, $120 radical 2 over 15. $80 over 15 radical 2. 24 radical 2 over 15. $144 minus 80 is 64 pi radical 2 over 15. Again, it's all algebra. If you want, did everybody know how I got from negative radical 5, radical 2 to the 5th to 4 radical 2? Show you. So negative radical 2 to the 5th. First off, negative 1 to the 5th is negative 1. So that the negative sign goes in front. Radical 2 to the 5th is radical 2, radical 2, radical 2. So here we have radical 2 squared. Here we have radical 2 squared, and that's just radical 2. So it's 2 times 2 times radical 2, which is negative 4 radical 2. Yes.
Wouldn't it keep the negative at the-
This one?
Yeah.
Well, it did, but then there was a negative in front, so I distributed it and changed the sign.
uh,
Where? Oh, in this page. On the left. This one?
one over-
It was positive. Because on the left-hand side, where's that? We took the positive radical 2. So all of these are with respect to radical 2. And since the sign's already positive, it stays positive. On this side, I use this one. So it's this one minus that one. What's the hardest part? I know, okay, I'm not gonna lie to you. It's easy, but it's not easy. Because there's a lot of moving parts here. But the calculus part was right here, setting it up. Once we got this, that's calculus. The rest is algebra. All right, now let's move on to the last of the 3 methods, the disk method. I mean, the washer method. Revolution of solid. The washer method. Before we begin here, we have to agree what we mean when we say washer. Not the laundry machine, but a washer in construction. It's a metal disc with a hole in the middle. That's a washer. So basically, what this is going to say, tell us to do, is, let's look back out in calculus 1. If we had two functions, this is f of x and this is g of x, and we want to know the area between, if we want to know this area between the bounds of a and b, what we would do is we take the larger function, the outer function, minus the inner function, and integrate with respect to that. Because remember, g of x is everything down here. So if I take f of x, which is everything, minus this, I just get what's between there. So using the washer method means that we're going to subtract two functions from each other. So let's take what we have here and rotate it about an axis. Here's our g of x. Here's our f of x. If we rotate about the x-axis, this is what we're going to get. We're only looking for the area between those guys. We don't want this area. So how do we do that? The same way. We're gonna take the two functions and subtract them from each other. So it's the larger area minus the smaller area. Let's look at the example here. Well, let me first give you the formula. The formula we're going to use for a washer method is going from A to B. The area is now going to be the larger outside one minus the inside one. Obviously, this is about the x-axis. We do the same thing with the y-axis. If we have time, we'll do that. All right, so let's look at an example here. Okay, the region bounded by the curve, this is the first curve, x squared plus 1, and the line negative x plus 3 is revolved around the x-axis to generate a solid. Find the volume of the solid. So whenever you're given two functions, obviously we have to use the washer method because there'll be one outer, one inner function. So let's see what this looks like. Let's see if we can draw the picture first. Y equals x squared plus 1. Y equals x squared is a parabola. When we plus 1, then it's raised up one. So that's y1. y2 is the line negative x plus 3. So we have a y-intercept at 3 and down 1 over 1. So bound by the curve that, so we want this area here. They intersect at 1, 2. And the other side, they intersect at squared minus 2. Negative 2. Yeah, they intersect at negative 2, 5. Okay, so what do we have so far? We drew the picture. We have to have two functions, the outer and the inner. The bigger one's the outer, and the middle one, or the smaller one's the inner. Interesting. Okay. We rotate about which axis? Revolve around the x-axis. So we're going to revolve this way. Interesting. Okay. Anyway, so what's r squared or large R? What's that one going to be? Which is the outer one, the higher one? Negative x plus 3. Right. It's the g of x. This is f of x. This is g of x. All right. So the smaller one, the lower one is okay. We have that. Now, what are our bounds of integration? Okay. To find this, I did that in my head. So the bounds of integration. Set the equations equal to each other and solve. So we got negative x plus 3 is equal to x squared plus 1. Since it's a quadratic equation, we have to move everything over. So we get x squared plus x minus 2. If you can't factor it, then use a quadratic formula. We know the signs are opposite because it's negative. What times what is 2? When you subtract them, you get a positive 1, positive 2, and negative 1. Set those equal to 0. So those are our bounds of integration. From -2 to 1. You have to find where the graphs intersect, because those are your higher and lower bounds. So the formula is r squared x minus little x dx. So large, it was -x plus 3 squared minus x squared plus 1 squared dx. I got those from what we had up here. So I have to FOIL both of these. It'd be x squared minus 6x plus 9, x to the 4th plus 2x squared plus 1 . Yeah, that pi can come out. It's constant. Distribute this negative sign. We have negative x to the 4th. That becomes negative. That becomes negative. So negative 2x squared plus x squared is minus x squared. Minus 6x plus 8. Now we integrate it. Negative x to the 5th over 5. X cubed over 3. X squared over 2. 8x from -2 to 1. Okie doke. Will be -1 over 5 minus 1 over 3. 6 divided by 2 is 3 minus 3 plus 8. That's the first part. Minus -2. Negative of -2 to the 5th over 5. -2 to the 3rd over 3. -3, -2 squared. 8, -2. So 15 is my LCD. 3, 5. 8 minus 3 is 5 times 15. We got -3/15. 5/15. (75/15). That becomes negative, makes it positive. 2, 4, 8, 16, 32/5 times 3. It's 96/15. Negative makes it a positive. 8/3 times 5. 40/15. -6 minus 16 is -22 times 15. (330). -8 plus 75 is 67/15. 138. So 330 minus 138. 291. That's 192. 67 plus 192. 259. (259 pi/15). Of course, there could be some easy math problems there. Now see what you guys get. You get the same answer? But yeah, this one, it could be about. But that's the way you do it. That's the mechanics of it. My problem is I try to squeeze it all into one piece of paper. Don't do that. I mean, it's going to be somewhere around there. It's a real number. It's positive at least. What time do you have to get out of here? Not 2. Or 12. It's 12:17 right now. Oh, you guys have another class right now. Because the last example is simply integrating with respect to y instead of x. But then again, I said the last one and it took forever. Let's try this one real quick. the region bounded by the parabola y equals x squared and the line y equals 2x two. We want this area here. So that one is y equals 2x. This one is y equals x squared. The outer bound is the 2x. The inner, the lower one, is x squared. Set them equal to each other. So we have our bounds of integration from 0 to 2. Oh, hold it. Yeah. This one's revolved around the y-axis. So I have to solve everything for x. So the first one, this one becomes x equals y over 2. X equals square root of y. We're integrating with respect to y. Since we're rotating about the y-axis, we're given the functions with respect to x, we have to solve for y. Solve for x, I mean. So those are our equations. Y over 2 equals square root of y. Square both sides. Y squared over 4 equals y. Y squared equals 4y. So our bounds of integration are from 0 to 4. Because you set the two equations equal to each other. So equation x1 equals x2. So then our volume is from 0 to 4 of pi r squared y dy. So big R is y over 2 squared minus square root of y squared. So it's y squared over 4 minus y. If I do that, it's going to be a negative. Oh, yes, yeah. Yeah. Because I switched it over from X to Y. Because originally this Y equals 2X was my outer one. And the other one, the X squared, was my inner one. But when I changed the bounds of integration, this one is now my outer one. So this is my outer one, this is my inner one. So these are swapped. Integrate those. Integration of Y is Y squared over 2. Y cubed over 12. Because there's already 4 down there, so we multiply it. Four squared over 2 minus 4 cubed over 12 minus 0. (16 over 2). This is 4 times 4 times 4. Makes it 16 over 3. Multiply by 3 by 2. 48 over 6. 32 over 6. Forty 32 is 16 over 6. So it's 8 pi over 3. Ta-da! That's all there is to it. So what parts do you see hard in this? Or any of these 3 methods? Is if you have 2 functions, then you have to use the washer method. You have to find the inner and outer function. If you have the disk method, you know the formula is pi r squared. If you have anything else before that, then it's just the functions. What's that? I believe so. Yes. And I'm so sorry about skipping that part in the middle. I had it on pause. I will find out which one where I messed up and I'll fix it.